The last section we're going to cover in Chapter 5 is Section 5.5. Thanks to Dr. Maroli, who felt that 5.4, which is simplifying complex expressions, really wasn't worth getting into, and it is pretty complicated stuff, and you've had plenty of complicated already. And you'll get some more of that in this chapter, 5.5. But what we're going to do is we're going to solve equations involving rational expressions. We'll start with some that are fairly simple and straightforward, and of course we'll get increasingly more complex problems. Then we're also going to take a look at proportions. But the first is this one, number 14, and if you look at it, the common denominator for 6, 4, and 4 happens to be 12, because 6 will divide into 12, 4 will divide into 12. So what we have to do is we have to take this x over 6 times 2 over 2 plus 3 over 4 times 3 over 3 equals x minus 1 over 4 times 3 over 3. When we do that, what we get then is 2x over 12 plus 9 over 12 equals 3 times x minus 1, which is 3x minus 3 over 12. Now, what we can do now that we have a common denominator is multiply through by 12 over 1. So if we take 12 over 1 times 2x over 12 plus 12 over 1 times 9 over 12 is equal to, we're having a little problems with our computer here, as you well know by now, 12 over 1 times 3x minus 3 over 12. What that does now is it eliminates all the denominators because these cancel each other out. That being the case, now what we end up with is 2x plus 9 equals 3x minus 3. Now what we'd have to do is just to solve that by subtracting 2x from both sides. And let me erase and do this a little further up because it makes it a little bit easier for us to finish that. Again, 2x plus 9 equals 3x minus 3. Now we subtract 2x from both sides. We get 9 equals x minus 3. And by adding 3 to both sides, we actually have a solution for this where 12 equals x. So if we were to go back into that original equation, putting 12 over x, we should get the same answer on both sides. 12 over x, or 12 being x, would be 2 plus 3/4, and then if you take 12 on the right side, minus 1, you get 11 over 4, and that happens to be 2 3/4. So we know our solution works. So that's problem number 1, or the first problem that we're going to encounter here. Let's take a look now at number 18, and the biggest difference between 18 and the one that we just did happens to be that now in the denominator, instead of having just numbers, what we've got are variables, x. And so to get rid of the denominator here, all we have to do is multiply each term by x. X over 1 times 4 over x minus x over 1 times 3 over 1 equals x over 1 times 16 over x. We didn't have to come up with a common denominator because we only had the one denominator, which was x. So that took care of that first step that we had in 14 where we had to find the common denominator. We don't have to do that now. So these cancel out and I get 4. In this particular case, now I'm going to take x times 3. I'm going to get negative 3x. And then those x's cancel there, and what I get is 16. Now if I subtract 4 from both sides, what I get is negative 3x equals 12. Now what I have to do, of course, is I have to take negative 3x and divide by negative 3, and I also have to take 12 and divide by negative 3. And so what I get is x equals negative 4. And that happens to be the solution to our problem. So now we've done 2 of those. Let's take a look at one that's just a little more complicated than those. Let's go ahead and take a look at problem number 24 that I have here written on the page. And I'm sorry we have to cramp some space in order to solve these, but let me see here. Oops. In 24, we have a common denominator. This time, instead of just being x, it's x plus 1. But that's the only denominator we've got. So what we're going to do is we're going to take x plus 1 over 1 times x over x plus 1 plus x plus 1 over 1 times 2 over 1 equals x plus 1 over 1 times 14 over x plus 1. What we do is now we eliminate all the denominators, and in the first case these two cancel out and all we have left is x. In the second case what we have is 2 times that quantity, x plus 1. That's one of the things you have to remember. You're multiplying that 2 times the quantity, x plus 1. And then in the last case, cancel out the numerator and denominator, we get 14. Now what we get is x plus 2x plus 2 equals 14. When we combine like terms, which we'll do over here on the right, what we get is 3x plus 2 equals 14. Subtracting 2 from both sides, what we get is 3x equals 12, and then 3x over 3 equaling 12 over 3, we get x equals 4. So it's kind of nice with these, we actually get a number or an answer for x. We're not simplifying expressions, we're actually solving equations. All right, now I need some space there, so we're going to go ahead and erase this. And now we're going to do number 32, and hopefully we've got enough space to do number 32 properly. Number 32, that's over on page 357. X over x minus 2 minus x plus 1 over x equals 8 over x squared minus 2x. In this particular case, what we need to do is we need to find out what the factors are. In this case, we have x minus 2, but we also have x plus 1 over x. And if we factor the denominator on the right side, what we come up with is x times x minus 2. So our lowest common denominator now is that x times x minus 2, because we have the x minus 2 term at the denominator of the first term in our equation. In the second term of our equation, we have the x in the denominator. So what we're going to do is we're going to multiply it all by that common denominator. So what we have is x times x minus 2 over 1 times x over x minus 2 minus x times x minus 2 over 1 times x plus 1 over x. And that's equal to x times x minus 2 over 1 times 8 over x times x minus 2. I'm sorry I'm pushing the border of the screen here. But what now we are able to do is in that first term we can cancel out the x minus 2's. And what we end up with is x times x. In the second case, what we end up with was we cancel the x's, and now what we end up with is minus this expression, x minus 2 times x plus 1. And now that equals, and we're canceling the entire numerator with the entire denominator, that just equals 8. So now what we need to do is we need to take an x times x gives me x squared. But I'm going to minus whatever I get when I multiply these two together, which is x squared would be minus 2x plus 1x. So that's just minus x. And then minus 2 times a positive 1 gives me negative 2 equals 8. Now, I went through that step pretty quickly. If you want to do the FOIL system, when you do that, you should come up with x squared minus x minus 2. Notice I put that in parentheses, though. That's important because I have that minus sign in front. This minus sign right here is going to change all the signs once I distribute that minus through there. So what I'm going to get next is x squared minus x squared plus x plus 2 equals 8. What happens is these two x squares right here, I've got a positive x squared and a negative x squared, they cancel each other out, and all I end up with is x plus 2 equals 8. Now if I subtract 2 from both sides, I come up with x equals 6. And fortunately for us, what they say is the answer to number 32 is indeed 6. So we're going to drop down and take a look at number 38. And with number 38, I'm going to need some space on the right. So what I'm going to do is erase what part of our solution there, so I have plenty of space to work. Now, notice, if you would, we take 2 over x plus 2 equals 3 over x plus 6 plus 9, and we factor x squared plus 8x plus 12. What we'll get, amazingly enough, of course, is x plus 2 times x plus 6. And we now know that x plus 2 times x plus 6 is our common denominator. So we're going to put that x plus 2 times x plus 6 over 1 times 2 over x plus 2. That's equal to x plus 2 times x plus 6 over 1, and that's times 3 over x plus 6. And then finally what we're going to do is plus x plus 2 times x plus 6 over 1 times 9 over x plus 2 times x plus 6. When we do that, we'll cancel the x plus 2 terms in the first part, and we'll get 2 times the quantity x plus 6. That is on the left side of the equation. On the right, the first term, we're going to cancel those x plus 6 terms, and we'll get 3 times the quantity x plus 2. And then finally, our last term, we can cancel everything, the x plus 2's and the x plus 6's. So all we end up with is plus 9. Now I've run out of space on the bottom, so what I'm going to do is I'm going to erase a little bit here on the right so I can finish this part over here. Hopefully you've saved that in your video. So what we have now when we distribute across is we'll have 2 times x plus 6. That turns out to be 2x plus 12. And on the right, we'll have 3 times x plus 2, which is 3x plus 6, and then plus 9. Combining like terms, we'll have 2x plus 12 equals 3x plus 15. Now, the larger value of x happens to be on the right, so I'm going to subtract 2x from both sides. And I get 12 equals x plus 15. But now to isolate the x, we have to subtract 15 from both sides. Now on the right, I just have x. I have 12 positives, 15 negatives. The difference of that is -3. And for number 38, what they say the answer is -3. So now what we've done is we've solved some equations involving expressions. We want to drop down and take a look at some proportions, and we're going to look at one story problem that's on the next page. So what I'm going to do is I'm going to erase, and we're going to drop down further on page number 357 to take a look at some proportions. I know you've solved proportions before, but we just need to kind of talk a little bit about how proportions are solved. So if you'll be patient with me, we'll go ahead and erase the rest so we can set up our problems. And we're going to first look at problem number 56. 56 only because that happens to be a fairly simple proportion. 2 over 5 equals x minus 2 over 20. Now, if you recall in solving proportions, what we're going to do is called cross multiply. And what I like to do is always put my variable on the left. So if I take the denominator of that first fraction, 5, and multiply it by x minus 2, then on the right, I'm going to take 2 times 20. What I get is 5x minus 10 equals 40. Sorry about the background noise. They're doing some work outside. Now, if I add 10 to both sides, what I get is 5x equals 50. And then I take the 5x, divide by 5, equals 50, divided by 5, and I get x equals 10. So that was pretty simple and straightforward. If we take a look at number 64 now, this one's a little bit different in that we get 3 over x minus 3 equals 4 over x minus 5. Now when we cross multiply, it doesn't make any difference because we're going to have variables on both sides no matter how we do it, going this way and going this way. That makes the problem a little more complicated. So we'll take the numerator on the left, 3, and we cross multiply that with x minus 5 equals 4 times x minus 3. What we get then is 3x minus 15 equals 4x minus 12. The larger value of the x is now on the right, so we'll have to subtract 3x from both sides. And what we get is negative 15 equals x minus 12. And to isolate the x, we just add 12 to both sides. We end up with negative 3 equals x. So there you have a couple of the proportion problems. I'm going to scroll down here and take a look at problem number 74. I'm going to erase the bottom portion of these two problems here. You've got them on your video. In number 74, we have two similar triangles. So you can set these up in a variety of ways. The way I'm going to do is take that x in the smaller triangle and put it over the x plus 4, which is the longer side of those two sides. Now, if I do that in the larger triangle, I have to take the same relationship. So the corresponding side for x in the smaller triangle, on the larger triangle, that corresponding side is 2x minus 2. And therefore, it is over the corresponding side of x plus 8. You have to look at those two triangles to see what those corresponding sides are. So I put corresponding sides, the same corresponding sides in the numerator on both sides, and the corresponding sides in the denominator on both sides. Now when I cross multiply, this is going to get to be interesting, because now I have x times x plus 8 is equal to x plus 4 times 2x minus 2. So what we're going to end up with is x squared plus 8x equals 2x squared plus 4 or plus 8x minus 2x gives us a plus 6x minus 8. All right. Larger value of x squared happens to be on the right side, so I'm going to subtract x squared from both sides. And what I get is 8x equals x squared plus 6x minus 8. But I still need to get rid of the 8x. Subtract that 8x, and now what I get is 0 equals x squared minus 2x minus 8. What we want to do now is we want to factor that. And so when we go to factor it, we get 0 equals x minus 4 times x plus 2. All right, when we did that, remember what we had to do was then take x minus 4 equals 0 and add 4 to both sides. And we get x equals 4. If we did the x plus 2 equals 0, subtracting 2 from both sides, we come out with x equals a negative 2. And that negative 2 really doesn't work for us. We need a positive value, so what we're going to focus on is this answer right here, x equals 4. Now, what you want to do is you want to take a look at the sides that you have here. In the first triangle on the left, well, that was just x, so that's now going to be 4. And then the other side is x plus 4, so that equals 8. In the larger triangle, you had 2x minus 2, which is 2 times 4 minus 2. 8 minus 2 equals 6. And then we had x plus 8 for the larger side, and of course that's 4 plus 8, so that equals 12. And if you notice that the smaller side is half as long as the longer side for both triangles. In the smaller triangle, it's 4 and 8. In the larger triangle, it's 6 and 12. Now, we've talked about a lot of things, but I want to talk about one story problem. And that story problem is on page number 358. It has to do with distance, rate, and time. And they like distance, rate, and time problems. So let's just do this one problem as a review. Problem happens to be problem number 80. Gives you a lot of information, and to be honest, I had to think through this one to figure out how we were going to do that. What we've got is Janet and Michael took a canoe trip traveling 6 miles upstream along a river against a 2-mile-per-hour current. They then returned downstream to their starting point of their trip. Their entire trip took 4 hours. So we want to figure out what's their rate. All right? So in these relationships, one is distance equals rate times time. And then when you divide, you'll find out the rate is equal to the distance over the time, or the time is equal to the distance over the rate. So I have to figure out some kind of formula so that I can only have one of those three variables, distance, rate, or time. And I could set the distance as the same because distance equals distance, but now I don't know what's my rate and what's my time, and rate's really what I'm looking for. So that really wouldn't work for me. That's what I tried first. Then I looked at it and I thought, okay, if I took the time of the first one plus the time of the second one, that total time is 4 hours. We don't know how much time it took them to go upstream versus how much time it took them to go downstream. But what I do know is time is equal to the distance over the rate plus that distance over the rate is equal to 4. Now what I'm able to do is I'm able to plug in that distance because I know that the distance happens to be 6 miles up and then another 6 miles back. So 6 miles over the rate plus 6 miles over the rate equals 4. Now, what is the rate? Well, on the way up, they were going against the current. So they were going at the rate minus that current, which happened to be, I think, was 2 miles per hour. Yeah. So that was their rate, whatever rate they were doing, minus 2. And then when they were coming downstream, it was their rate, whatever that happened to be, plus 2. Now what I've got is I've got an equation where I'm only looking for one factor, and that's rate. Now my common denominator in this particular case has to be r minus 2 times r plus 2 over 1. So I multiply that by each factor, 6 over r minus 2 plus r minus 2 times r plus 2 over 1 times 6 over r plus 2. And then that equals r minus 2 times r plus 2. I can put it over 1, but we're just going to multiply that by 4. Whew, this looks like it's going to get complicated. So we can cancel out these, and we end up with 6 times the rate, r plus 2. And then the second one, when we cancel out the r plus 2's, we put plus 6 times r minus 2. And then we get on the right 4 times, and when I FOIL this, r minus 2 times r plus 2 is one of those special cases where it's r squared minus 4. Going ahead and distributing through, what we get is 6r plus 12 plus 6r minus 12 equals 4r squared minus 16. Combining like terms, what I get is 6r plus 6r gives me 12r. Minus 12 plus 12 gives me nothing, so 12r equals 4r squared minus 16. Well, now I need to set everything equal to 0, so I'll have to subtract 12r from both sides. And since we're at the bottom of the page, what I'm going to do is finish the rest of it up here in the upper right. Sorry about that. There we go. We're going to put it up here. Taking that, we might subtracted r squared, or 12r from both sides. We end up with 0 equals 4r squared minus 12r minus 16. Interestingly enough, we do have a common factor there, which is 4. When we factor that out, we get r squared minus 3r minus 4. So when we factor that now, what we get is 0 equals 4 times r minus 4 times r plus 1. And what we're interested in is this term right here. Because when we take that term, r minus 4, and set that equal to 0, we add 4 to both sides, and we get r equals 4 miles per hour. And that's our answer. A lot of work to get it, but we were able to do that.